You're ready, Ryan.
Cool, thanks, David. So I'm Ryan. This is a super fun paper with some really smart people. It's really easy to motivate this paper. So there are a lot of experiments on financial decision making, and they primarily use a lot of student subjects, which begs the question, well, we have these results with students. Do they account for what happens if we have professionals in the lab? So that's what we do here. And we can address questions like, do professional traders create asset bubbles? How do they price an asset? How well do they aggregate private information? What's their level of strategic sophistication? Also, what's their belief about the strategic sophistication of their peers? Which is pretty cool. So these are the kind of questions that I'm going to answer here. So I want to make a point in the beginning. We're looking at traders, like really front end guys, trading either currently on the markets or portfolio managers or had done so in the past. So we didn't just go to a bank or a firm and ask just everyone to participate in our experiment. We had a very refined idea of who we wanted, and we wanted tip of the spear front end traders. And in looking for these traders, we ended up getting 56, and we had them come to our awesome lab here in London, which is just on the other side of this computer. And they made up our trader treatment. So we had 56 traders, turns out 86% were male. And we're going to compare that trader treatment against the student treatment, which are undergrad students here at UCL. We tried to match it in terms of gender. We did a pretty good job. So there you go. We have 7 sessions for each treatment, and we have 8 subjects in each session. So subjects come into the lab and they make decisions in groups of 8, and that's what I'll be talking about today. So what types of tasks did we have them do in our lab? So we had 2 types of experiments, and they're both like a classic with a bit of a twist. So let me explain. So what I call the trader game is double auction of an asset with a declining fundamental value. It's really reminiscent of the Smith et al. Paper in 1988. There's a bunch of really interesting, cool papers based on this first paper. It's a classic. It would be interesting in and of itself just to see how professional traders behave in this classic environment. But we added a couple twists. One twist I'm going to talk about is we added private information, which I'll discuss when I get there. The second type of game we had the subjects play is guessing games, and 2/3 the average beauty contest from Rosemary Nagel's awesome 1995 paper. We had them do that. Again, it's a super classic. It's been done a lot. It would be interesting to see what professional traders do just in this classic game. But our twist here is after they play the original guessing game, we have a novel individual guessing game in which we can kind of tease apart a subject's ability to be sophisticated from their belief about the ability of others. So of course, that's going to need explaining when I get there as well. We looked at traders in these financial market environments because we expected them to behave differently than students. So we wanted to have an idea as to what mechanism might explain why they behave differently. So based on the literature, we collected some things like risk preference, cognitive scores, and confidence to see maybe these are mechanisms that could explain why traders behave differently than students. The one sentence takeaway from this paper, the summary of the main results are, traders in general make choices that are more consistent with the theoretical predictions, and this is not explained by risk preference, cognitive scores, or confidence. Now, that sounds rather boring and kind of dry. The presentation is more interesting than that, so don't go just yet. So let me go straight to the trading game. I'm going to kind of blend theory and experiment in my short amount of time. So agents trade an asset over many periods. In our experiment, they have 10 discrete periods, and they're trading an asset. Why does anybody want this asset? This asset is desirable because it pays off dividends, and the dividends are either low, 50, or high, 150, with equal probability. So the way we start the market is in period 1. Each agent, each subject is given an endowment of 3 assets and 7,000 in cash. And then in period 1, they trade in a double auction for 150 seconds. And at the end of 150 seconds, period 1 is over and they move to period 2. And in period 2, they get the portfolio that they ended up with in period 1. So this is generally the case. The portfolio of cash and assets that you have at the end of one period transfers to the next. So for example, in period 1, suppose I sold an asset for 1,000. Starting in period 2, I would have 2 assets and 8,000 in cash. And the asset has no residual value after period 10. So that means, of course, it pays the dividend in period 10, but there's no extra bonus no extra bonus for holding the assets. So what subjects try and do is they get paid based on how much cash they have at the end of the experiment. Yeah, and this is a really standard setup, nothing really fancy here, so on. So this is the bones and structure of the trading game. And then we have this introduction of private information. So we're not the first one to study private information, but this is how we do it. So in every period, subjects get a private signal about, is the dividend going to be high or low in that period? And the signal is correct with 75% chance. So what that means in the experiment is that if we're in a period where the dividend is going to be low, 6 subjects get a red ball and 2 get blue balls. If we're in a period where the dividend is going to be high, 2 get red balls, 6 get blue balls. So if you're a subject in my experiment, in a period, if you get a blue ball, that's a private signal saying the dividend's probably going to be high in this period. So aggregating all the private signals perfectly reveals the dividend in every period. So that leads us to the equilibrium of what should we expect to have happen. What should the price be of an asset in every period? So as I said, private signals are perfectly aggregated by the price, and the price simply should equal the asset's fundamental value in any period. So what that means is rather simple. So it's how much does the dividend pay me today in this period, and how much do I expect the dividend to pay me in all the remaining periods? So for example, we can look at period 1. So in period 1, the expected value of what an asset's going to earn you in periods 2 through 10 is 900. So that's how much it's going to give you if you hold on to it for periods 2 through 10. But what about in this period? Well, it depends. If the asset's low, then the price will end up being 950. If the dividend is high, then the market clears at a higher price of 1050. So we have this table here on the bottom, which shows what we theoretically expect to have happen in every period. So you see in every period, the equilibrium price depends on the dividend in that period. So 950 or 1050 in period 1, all the way to the last period where it's either 50 or 150. So I should contrast this with what would happen if we didn't have private information. So if we didn't have private information, in period 1, the dividend, the equilibrium, the fundamental value should be 1,000. Then in 2, it should be 900, 800, 700, and so forth. So that's the standard way to do it. If we didn't have private information, we would have that type of declining fundamental value. But in this case, we still have a declining fundamental value, but it's got this twist because of the private signals. Okay, so that's what we expect to have happen. Let's look at what actually happened. So I have 2 figures here. On the left is for the traders, on the right is for the students. On the x-axis is the period, the y-axis is the price. And the fundamental value for each session, remember each group has 7 sessions, the fundamental value depends on the realization of the dividend in every period. So that's why you have this wobbly line here. This dotted line represents the median of all 7 experienced fundamental values. Okay, so this is what we expect the subjects to do roughly. And before I show you what they actually did, let me show you what we expect from previous papers. So this is a previous paper. This is not a specific paper. There are many papers that show this behavior. And again, this Pellin 2013 paper, on the x-axis is period, y-axis is price, and then you can see the fundamental value is declining in this paper. And these dots and jaggedy lines are the prices that the subjects did. These were student subjects. And they demonstrate a rather standard behavior. Super low prices in the beginning, well below the fundamental value. It crosses over the fundamental value, stays above the fundamental value for quite some time, and crashes back down to the fundamental value only at the end of the experiment. So this pattern of mispricing is standardly observed, and this is what they call a bubble in these types of experiments. Okay, so that is what we expected to see with our subjects. Let's go back to our data. What do we actually see with our subjects? So let's look at the students first. This is the median price for each of the 7 sessions. This is the median over all prices. And what we get is basically exactly roughly what we expected to get. Price is too low in the beginning, crosses over the fundamental value, stays above the fundamental value until the very end, and then it crashes. So with the students, we got what we expected. Now let's turn over to the traders. This is the median price path for each of the 7 sessions. This is the median over all 7 sessions. And what we can see is that the traders did a lot better job pricing the asset. The dark black line is a lot closer to the dotted line. It's clear if you just showed me these 2 figures that these are 2 different groups. We don't have to just rely on our eyeballs to see that. We can get some statistical significance as well. So each session can be attributed roughly the average, how bad of mispricing was it, using this relative absolute deviation, RAD here. So we can give a number to each session about how bad of the mispricing was it. And when you do so, the 7 trader sessions were significantly more accurate, showed significantly less mispricing than the 7 student sessions. If you calculate like a similar type of metric, period by period, the biggest difference between traders and students were in period 6, 7, 8, which isn't surprising. You can actually see that on the graph. In period 6, 7, 8, you can see that's when the students were in the throes of a bubble and the traders were not. Another thing we can see using these figures here is in every session, there was a period that recorded the peak price in that session. So take a session what period had the highest price. Theoretically, this should be either in the first or second period, which for all 7 trader sessions, we see it's in the first or second period, which is very different than the students. You see for the students, 4 sessions had their peak price period in period 5 or 6, which of course is what you'd expect with bubble sessions. So again, just using this metric here, it looks like the traders did a much better job having their peak price period early on, and statistically, that is true as well. So what we learned from this picture here is that traders price the asset more accurately than do students. So now we can look at private information. So that's the twist we have here is private information. So how well do traders and students act on the private information they get? How well do they aggregate private information? And the way we did that was we looked at how price changes across 2 periods. Let me show you what I mean. So if the price changes in 2 periods, goes from high to low, for example, in period 1 and 2, we expect the equilibrium says that the price should drop by 200. That's one setting. Another setting is if the dividend was the same in 2 periods, either high, high, or low, low, in which case the equilibrium predicts that the price should drop by 100. And then the third setting is if you go from a low dividend period to a high dividend period, in fact, the price shouldn't drop at all. So we have these 3 different periods, which have 3 different theoretical predictions for how much the price should change. And the question is, how well did students and traders in these 3 different categories respond to the signals? So what you have here is you have the 3 different categories. You have high, low on the left and from low to high on the right. And the red horizontal bars represent the theoretical predictions that I just talked about on the previous screen. So the first thing to look at probably is the students. They're the light gray bars here. So here, here, and here. And you see no matter what category they're in, whether they're going high to low, low to high, or whatnot, they decrease their price by 50 no matter what. This is pretty clear evidence that they're not using the private signals at all to change the price. In contrast, the traders do a pretty good job. Now, they don't do a perfect job. They're not perfectly getting down to the theoretical predictions, but they do see the biggest price drop when the theory predicts they should have a big price drop. And when the theory predicts they shouldn't drop the price at all, indeed, the price doesn't drop at all. So what we learn on this screen is that traders aggregate private information better than students. Students don't seem to do it at all. Traders do it to some degree, although not perfectly. Okay, so let me turn to the guessing game now, which is awesome. Super interesting experiment. What I love about it, it says something interesting about human behavior, and you can put it all on a screen right here. So these are the verbatim instructions the subjects got. Let me explain it to you briefly. Each subject entered a guess. So subject entered a guess, and the other 7 subjects entered a guess. These 8 numbers were averaged, and divided by, or multiplied by 2/3, excuse me, and this became the target number. And whoever guess is closest to this target number gets 5 pounds, everyone else gets nothing. That's highly likely most people in the audience are familiar with this, this experiment. And it's really cool. As you know, the Nash equilibrium is everyone guessing 0. Of course, that's not what we observe. That's what makes this kind of interesting, is that the choice in this simple experiment can reveal a level of strategic sophistication for a subject. So let me explain. So if I think I'm going against a bunch of random opponents who are picking randomly between 0 and 100, that average is going to be 50. So I should best respond to that, which is 2/3 of 50, which is roughly 33. So that would be called a level 1 subject. Now, if I think that, if I realize how to do that, I might think, well, everyone else is going to do that too. So if everyone else is level 1, if everyone else is picking 33, the best response to that is 2/3 of 33, which is roughly 22. And then you can keep, that'll be a level 2 subject, and you can keep going higher and higher levels with lower and lower numbers. So what we get from this experiment is subjects who enter lower guesses, lower numbers, are demonstrating behavior consistent with higher levels of strategic sophistication using the theory of level K. Okay, so that's the guessing game instructions. What do we see the subjects actually do? So this is the raw data. This is what the students, excuse me, this is the student raw data. As we show in the paper, this is very consistent with what we typically see with students in this type of guessing game environment. And here's the raw data of the traders. And it's very clear they're different. And maybe it's clear that the traders enter lower numbers than the students. And in fact, it's statistically significant that that's true. This would suggest that lowers have higher levels of strategic sophistication because they enter lower guesses in the guessing game. So these are just their raw guesses. We could also classify subjects based on these two papers here into these different levels. And we see that the level K theory classifies about 61% of both the traders and the students. So it's not that the level K theory is better at explaining the behavior of the two. But within the theory, so what you notice, what stands out, is that traders are way more likely to be these infinitely rational type subjects. They're way more likely to enter numbers between 0 and 1. And in fact, this is statistically significant. So what we've learned from the past two screens is that traders make choices in the guessing game consistent with higher levels of strategic sophistication than do students. I love the guessing game. I really do. There's one small issue with it that I have that you may have as well, and it gets illustrated here. So imagine a subject enters 33 in the guessing game, and I'm trying to analyze what was going on in that subject's head. So there's two possible explanations. So first, the subject can't reason below 33. So they think everyone is a random decision maker, and so they pick 33, and they don't know how to reason to these higher levels to get down to 0. That might be a reason someone would enter 33. The second one is that, well, in fact, the subject can reason further, but he or she doesn't think that their peers will do so. And that's why that person put 33. So we have a bit of a mix-up about a subject's ability to strategically reason and their belief about the ability of their peers. So the way to try and get around that is what we call the individual guessing game, which is novel to our experiment. And it's really quite simple. So in the original guessing game, so I should say, they play this individual guessing game right after the original guessing game. And the only difference here is now all 8 guesses are entered by the subject. So subject enters 8 guesses, and that subject's target is 2/3 times the average of the 8 numbers that they entered. So we take the target number from the 8 numbers that the subject had entered, and we take one of their guesses picked at random, and if that guess equals the target number, then they get 5 pounds. If not, then they get nothing. So someone familiar with level K, or even if you think about this for a while, it's clear to see that the only way to guarantee 5 pounds is to enter all 8 zeros. So the idea is that if you get the individual guessing game correct by entering all 8 zeros, you're someone who has a very high ability to reason in the guessing game. Your ability is infinitely high. You can reason yourself all the way down. But we're interested in how these, I'm just going to say, infinitely high reasoners, how do they make decisions in the original guessing game? So let me show that. So first I should say,
Ryan, I'm sorry to interrupt.
Yes,
This a very quick clarification questions. I'm going to read the questions. So do they play with the same 7 subjects with whom they play the asset market?
yes.
Do the deviations, okay, the answer is yes. Do deviations from fundamental prices predict higher numbers in the guessing game?
Deviations from the fundamental value predict
fundamental prices predict higher numbers in the guessing game.
So that's a bit hard to say. So a deviation in the trading game is a market environment with many people, and even a trade necessarily requires one seller and one buyer. Whereas the guessing game, of course, involves other people. But so we haven't looked at that, is the short answer. And it's not entirely clear how I would do that. But let me say in the aggregate level, traders have less deviations from the fundamental value, and traders were more likely to enter lower numbers. So on that very meta aggregate level, it's true. More specifically, like within sample, which I think is what the question asks, I don't have an answer about that. That's a good question, though.
All right, so another question. So you're going to decide whether you're going to answer this question or maybe, save the question to the end. So why don't you do the 2-person guessing game that has a dominant strategy?
I mean, so we were interested in the guessing game without a dominant strategy, because then we have these different levels, and we wanted to see how traders match up in these different levels. So we really wanted to go with the not dominant strategy on purpose, and then we have this interesting individual guessing game to disentangle this extra piece. So it could have been interesting, but we picked the more common one without a dominant strategy. Because I mean, what's great about the guessing game is it has these different levels without the dominant strategy. That's a good question, though. Any more, Sherry?
Another clarification question, if I could. So were the stakes the same for students and traders? And if not, how were they calibrated?
What a terrific question. So the stakes we paid the traders more in the trading game. There's a long discussion behind this, but we paid the traders 10 times as much in the trading game as we did the students. But in these other games, we paid them the same. Very good question.
Okay, thanks.
Terrific. So let me explain the individual guessing game and the results here. So, so who got the individual guessing game correct? So 11 traders and 10 students did. So that means we don't see a difference in terms of, if you think about the individual guessing game maybe as a cognitive test, we don't see any difference here in terms of traders and students. But what we have now is we have these 21 subjects, all who've demonstrated that they have very high levels or infinitely high levels of ability to rationalize down to 0 in the guessing game. And how do they, holding constant their ability, how do they make decisions in the guessing game tells us something about their belief about their peers. So this maps the 21 choices of the guessing game for these subjects who got the individual guessing game correct. And so these students, you can look in the foreground at these light bars, these are students what I'm saying, infinitely rational, yet they inserted guessing game choices between 30 and 35, suggesting, yeah, I get the game, but I don't think my peers are going to get the game. So I'm going to put between 30 and 35. In contrast, the traders, very high rationality traders, put really low numbers. So the traders say, yeah, I get the game, and my peers are also going to get the game. So this tells us that, at least in part, the traders have different belief about their peers than do students, and they think that their peers are more likely to have higher levels of strategic reasoning. Let me quickly conclude about the 4 things that I made a big deal about. In the trading game, traders price the asset more accurately than students, and they aggregate private information better. And then in the guessing game, they exhibit higher levels of strategic sophistication by entering lower numbers, and this is at least partially explained by the fact that traders think that their peers are higher levels than do students.
So Ryan, you're at the 1 minute mark.
Terrific. I will take this 1 minute to talk about the things that we tested at the end. So you might think traders are different than students because they're smarter, they're less overconfident, or they have higher risk aversion. So we wanted to see if this could explain our results. We don't find that traders are any smarter. In fact, they're smarter in one test and score less well in the other tests. So they're not dominant in cognitive abilities. Neither group is more overconfident, so confidence cannot explain our behavior here. And the final one is you might think a group with higher risk aversion would be less likely to, for example, bubble. But in fact, we find the opposite. Traders are less risk averse than students. And so I'm done. Thank you for your time, and we turn it over to the discussion or questions.
Thank you very much, Ryan, for